What's up, y'all? Today we're going to be going over integrating factors, and this is one of the ways that you will solve first order linear differential equations. So I'm going to write down a formula up here. I'm not going to prove it. You can just consult your professor or just look up a different video. I'm just going to show you how to solve these equations and evaluate them as t approaches infinity. So we have 1 over mu of t times the integral of mu of t g of t times g of t dt, where mu of t equals e to the integral pt dt. Now pt is going to be this term that is in terms of t or not. It could just be a constant. Definitely not any it's what's attached to this value of y. So if you were to have ty prime plus y equals 1, you would have to first get y prime by itself, so you divide everything by t. Y prime equals 1 over t times y equals 1 over t. So we've divided everything by t. Your p of t in this case is going to be 1 over t. And that's what we're going to plug into this to find mu of t. I'll go ahead and do an example and show you how it's done. So this first problem that we're looking at is going to be y prime plus 4y equals t plus e to the power of negative 2t. So let's go ahead and get started on this. We'll see that first note that y prime is alone, and this is in terms of t or just a constant, which is fine. It's p of t, so p of t equals 4. And then this is all in terms of t, so this is our g of t. So g of t equals t plus e to the negative 2t. And then mu of t is going to equal e to the integral of 4 dt. So mu of t equals e to the 4t. Because the integral of 4 is just 4t. We don't have to worry about the constant of integration when we're considering mu. So it's just e to the 4t, not e to the 4t plus c. So now we can set up what our solution is going to be. Our solution is going to be the answer of this, basically. It's going to be the equation that this gives us when we're dealing with first order linear equations like this. So y equals 1 over mu, which is e to the 4t, times the integral of mu of t, which is e to the 4t, times g of t, which is just t plus e to the negative 2t dt. So y equals 1 over e to the 4t times the integral of t e to the 4t plus, e to the 4t times e to the negative 2t. Whenever you're multiplying something with the same base, you can just add the exponents together. So 4t minus 2t is just 2t. E to the 2t dt. Just like that. So for this first part, we're going to have to use integration by parts. So we can set u equal to t and dv equal to e to the power of 4t, du equaling dt because we take the derivative of u, and then v equaling 1 over 4 e to the 4t. So that's an e. Okay. So now we do y equals 1. Instead of using 1 over e to the 4t, just to make it look a little bit nicer, I'm going to use e to the negative 4t. I hope you understand it's the same thing. So e to the negative 4t multiplied by the integral of t times e to the 4t. Well, we know by parts that it's uv minus the integral of v du. So uv is going to be 1 over 4 times t e to the 4t, which is, okay. So 1 over 4t e to the 4t, and then minus the integral of v du, which is 1 over 4 e to the 4t dt. And then don't forget that we also have this part of it, right? This is still part of the integral. We only did this part right here. So plus the integral of e to the power of 2t dt. And that is going to give us y equals e to the negative 4t 1 over 4 t e to the 4t minus the integral of 1 over 4 e to the 4t is going to be 1 over 16 e to the 4t. Yep. And then plus the integral of e to the 2t, which is just 1 over 2 e to the 2t. And we are worried about c right here. We're going to add in our constant of integration at the very end. And so we can now simplify this and get a solution. So let's go ahead and do that right above here. So now let's distribute this e to the 4t, e to the negative 4t, and we'll pretty much be done with this problem. So e to the negative 4t, e to the negative 4t times e to the 4t, well, negative 4t plus 4t is going to be e to the 0 power, which just equals 1. So that whole thing is going to turn to 1. So you'll have 1 times 1 over 4t. And then you'll have e to the 4t minus 1 over 16 e to the 4t. So that's going to be negative 1 over 16 for the same reason. E to the negative 4t times e to the 4t, negative 4t plus 4t equals 0, e to the 0 equals 1. So now e to the 4t, or e to the negative 4t times e to the positive 2t, that's going to yield e to the negative 2t. So it's going to be plus 1 over 2e to the negative 2t. And then e to the negative 4t plus c is going to be plus c times e to the negative 4t. And this should be your answer. Make sure that that's right. Yep. Okay, so now that this is your answer, you're trying to find the limit as t approaches infinity. So when you are evaluating the limit as t approaches infinity, you're basically saying, well, what happens when I plug in really big numbers at t right here, right? So it's negative 1 over 16 is pretty negligible. It's going to go away. This is going to go to 0 because this is 1 over 2 e to the t, 1 over 2 e to the 2t. When you plug in, as t approaches infinity here, this is also going to go to 0, this is going to go to 0. This, however, this part of it is going to go to infinity. So every term after this is just, that's negligible. This is going to go to 0, this is going to go to 0, this is going to go to infinity. So as t approaches infinity, y is also going to approach infinity, positive infinity. So that's pretty much like a simple evaluation of how to evaluate once you find your answer. Just looking for like in-term behavior, and you'll see why that's important when you apply it in section 2.3. So let's go ahead and do another one. Okay, so we have y prime minus 2y. Okay, this is going to be one of those ones that is going to take some practice in order to see why you mess up, because this one's pretty easy to mess up, or at least I did all the time when I first started these. So y prime minus 2y equals t squared e to the power of 2t. So now what we're going to do is remember this formula up here. I know it's a little hard to see because I don't have a lot of room to work here, but just refer to the beginning of the video or just jot that down when I wrote it big here. So we have mu of t equaling e to the integral of p of t, and p of t isn't just 2 here, it's a negative 2, and that is something that you will have to look out for because it'll get you. It definitely got me a bunch. So negative 2 dt, so that means mu of t equals e to the negative 2t. And g of t equals t squared e to the 2t. Right? So, now that we have mu of t and g of t, it's always best whenever you get it in this form to just define what mu of t are and what g of t are, and then you can go from there. I like to write, so when I have mu of t equals, this might mess some people up, but I like to say it's the first term is the opposite of whatever the opposite. If it's positive, then it's going to be negative. If it's negative, it's positive. But if you can see why 1 over e to the negative 2t is just equal to e to the 2t, because 1 over e to the negative 2t is just equal to 1 over e to the 2t, which this just comes up front, right? And then it's going to just be e to the 2t. So out front you're going to have an e to the 2t, because it's 1 over mu of t. And let's see. I'm going to write this to the side just so I don't get confused. 2t equals e to the 2t. So e to the 2t times the integral of mu of t, which is e to the negative 2t, times g of t, which is t squared times e to the 2t dt. So when you multiply these two together, you get negative 2t plus 2t, which is just 0, and we know that e to the power of 0 equals 1. So these two cancel, and you're left with e to the 2t times the integral of t squared dt, right? So this is a pretty simple integral, right? So you just have e to the 2t times 1 over 3 t cubed, because 1 over n plus 1 times t to the n plus 1. So integrate. So 1 over 3 t cubed, and then we are worried about the constant of integration right here. This is equal to y. This thing, crazy. Okay, so y equals e to the 2t times this integral right here, which is 1 over 3 t cubed plus c. So now we can simplify this, and we can combine. I mean, I guess you don't really have to, but I like to do it. E to the 2t, put the t term first, just to make it neat. So 1 over 3 t cubed e to the 2t plus c times e to the 2t, and this is going to be your answer, right? Do y equals, actually, yeah. So this is going to be your answer, and that's little y. And we're now going to evaluate what happens whenever t goes to infinity. Make sure that's right. Yeah. So as t approaches infinity, what's going to happen to y? Well, this is going to be really, really big, right? This whole part is going to be really, really big. This is going to be really big also. I don't think that it matters if c, yeah, it's not going to matter if c is positive or negative, because this is going to outweigh that. So this will always be a higher power of infinity. So as t approaches infinity, then y will also approach infinity. So that is how you evaluate that. Let's do, actually, let me see how much time I have. Okay, I'm gonna stop this video for now, and then I'm gonna stop it, and then we'll come back and I'll do a couple more. So. Alright, so the next one we're going to do is y prime minus 2y equals 3 times e to the power of t. Watch that negative, remember, that will mess you up really bad. So now we're going to define mu, right? Mu of t equals e to the integral of -2 dt. So mu of t equals e to the -2t. We're not worried about constant integration here. G of t is going to be equal to, and if you're wondering why we're not worrying about the constant integration, consult a video on the proof of this, or ask your professor. So now g of t is just going to be what's on the right hand side of the equation, as long as it's in terms of t, and as long as this looks like it does, not having a term of t here, and having some function of t, it doesn't just have to be a constant, attached to y. So g of t equals 3 times e to the power of t. So now let's set everything up and integrate. So we know that 1 over e to the -2t is just equal to e to the 2t. So let's use that instead, 'cause it's a little bit more simple. So e to the power of 2t times the integral of mu of t, which is e to the -2t, times g of t, which is 3 e to the power of t, dt. And these are the same terms, so we can combine them. E to the -2t times e to the t, that's going to give us 3e to the -t. So e to the 2t times the integral of 3 times e to the -t. Some sloppy handwriting today. 3e to the -t, yep, dt. So now that we have that, we can integrate this, and that gives us e to the 2t times the integral of 3e to the -t is going to be -3e to the -t, because when integrating e, you don't change the power, right? You just take whatever's in front of it, in this case -1. So 3 over -1, which is going to give us a -3. And we're worried about the constant integration here at the end. So now we're left with y equals -3 e to the I'm going to go ahead and distribute this e to the 2t. That's what I was doing. So -3 e to the -t times e to the power of 2t is going to be e to the t, right? 2t minus t. So 3 e to the -3 e to the t, and then plus c times e to the 2t. And this is going to be our answer. So now we want to evaluate this solution. Make sure it's right. Yep, okay. So now we want to evaluate the solution as t approaches infinity, right? So it's going to take a little bit of an in-depth glance at it. Just more in-depth than normal, but you'll see what I'm talking about. It's not that bad. Okay, so we know that as t approaches infinity, so what's going to happen when t approaches infinity? Well, in this case, it's going to depend on c, because c has the higher power of t, right? So as t approaches infinity, if c is greater than 0, so what's going to happen if c is greater than 0? Well, if c is positive, right, greater than 0, then this y value is going to be approaching positive infinity, right? But what if c is less than 0? Then if it were less than 0, then this would just end up being like a really big negative number. So then y would approach negative infinity. If you're confused on that, just try and just plug in like a really big value of c, right? Plug in like 1,000,000, and then well, that's not a good example. it has to do with just like calculus 1 and being able to kind of imagine where things are going to end up in the long run. If you are confused on it, I can't really think of a better way to describe it right now. Feel free to just message me, and I'll try and walk you through it. I'm even open to like doing like Zoom meetings and stuff, or whatever works best. So if c is greater than 0, then y is going to be positive infinity. Y is going to approach positive infinity because the 2t overpowers the t. If c is less than 0, if c is negative, then the whole thing is just negative, and it's going to approach negative infinity. So let's do another one. So ty prime plus 2y equals sine of t, where t is greater than 0. So now there's a problem with this, right? Because we have t in front of the y prime, so what are we going to have to do? We're going to have to divide everything by t in order to get in order to get it in the form that we want. It will take this, we'll have a 2 over t right here, but that's still a p of t, right? Because mu of t equals e to the integral of p of t dt. It's a function of t still, so it'll work. So just bear with me, and we'll get through it. So divide everything by t. So we'd have y prime plus 2 over t times y equals sine of t over t. So now that we have it in this form, we can now identify what mu of t and what g of t is. So mu of t is going to equal e to the integral of p of t, which is 2 over t dt. Right? And I know that looks a little complicated. It's just like an algebra thing, right? So it's not that bad. Not the integral part, but what's coming next, because I think you might be able to see it. So the integral of 2 over t dt is going to be 2 times the natural log of t. We're not worried about absolute value of t because it was defined early in the problem that t is always greater than 0. We don't worry about the constant of integration here. So now this is the same as writing this by using powers of logs. Natural log of t squared, that 2 can just jump up to the power. That's just the rule of logs. And then these are inverse functions, so mu of t is actually going to equal to t squared. If you are confused on this, what I always do, just to like, if I'm second guessing myself, what I do is I take my calculator and I'm like, well, I can take e and raise it to the power of the natural log of 4. And will it give me 4 back? And it does, right? And if I'm like, well, what if that was a coincidence? So e to the natural log of 70 still gives me back 70. So I know that it's just a way to double check. I usually do that like on tests and stuff, just in case like, and not with this, but just in case I second guess myself for whatever reason, if I'm just like asleep that day or something. So mu of t equals t squared. So now we can, and we know that g of t equals sine of t over t. Right? So now that we have those two values, we can plug into our integrating factor formula and find the solution to this differential equation. So 1 over mu of t is equal to t squared times the integral of g of t, which is sine of t over t times t squared dt. So mu of t is t squared, g of t is sine of t over t. So this is going to give us y equals 1 over t squared times the integral of t sine of t dt. Okay, so now we can use parts. And we set u equal to t because we want the descending power. We want the powers to go down so we can get rid of it, right? We set dv equal to sine of t. V is going to be negative cosine of t. So we are left with y equals 1 over t squared times definite rule. We're going to have uv, right, negative t cosine of t, minus the integral of v du, negative cosine of t dt. And we're going to wait to put that constant of integration until after we solve this integral, this last integral. So now let's go ahead and solve this last integral. Y equals 1 over t squared times negative t cosine of t plus, because I'm pulling this negative out, it becomes a positive, plus the integral of cosine of t, just normal cosine, right? Because I'm pulling this negative out. The integral of cosine is just sine of t, plus c. Okay, so now we're getting really close, right? We can distribute this 1 over t squared. So we're going to get negative t over t squared is going to be negative 1 over t cosine of t plus sine of t over t squared plus c over t squared. And this is going to be your answer, your solution to your differential equation. Now let's evaluate what's going to happen as t approaches infinity. Well, if you look at the sine and cosine functions, they're going to be oscillating, right? But it's really not going to matter because they all are going to be divided by t, and as t approaches infinity, they're all going to be like really close to, they're going to just approach 0. So this is going to go to 0, this is going to go to 0, this is going to go to 0, no matter what c is. So as t approaches infinity, y approaches 0. So that is that problem. Here's your answer. See how much time I'm working with. One more in here. Alright, so let's look at another problem. Let's see if this is a long one. I might have to pause the video, make another one and attach it. Oh, maybe that bad. Okay. So now we have y prime plus 2t y equals 16t e to the negative t squared. This might take me longer than 8 minutes. I'm not sure. I'm just going to stop the video just in case. Be right back. Alright, back with another problem for you, integrating factor. So we have everything, the y primes alone, which is good. We have a function of t in front of this y, which is also good. We have a function of t on the right hand side, which is our g of t, which is in the form we need it. So what we're going to do is we're going to just define mu of t and g of t. So mu of t is going to equal e to the integral of p of t, which is 2t dt. So mu of t equals e to the power of t squared. G of t equals 16t e to the negative t squared. So now we have mu of t and g of t defined. Let's go ahead and plug it into our formula and find the solution to this differential equation. So 1 over mu of t is going to be 1 over e to the t squared, which is the exact same thing as e to the negative t squared, right? So let's write it like that because it's a little bit more convenient. Times the integral of mu of t, which is e to the t squared, times g of t. 16t e to the negative t squared dt. Well, this is convenient again, right? Because you can multiply e to the t squared times e to the negative t squared minus t squared equals 0, e to the power of 0 equals 1, so that's all going to cancel and go away. So since that's going to cancel and go away, we have y equals e to the negative t squared times the integral of 16t e to the negative t squared. So this is the only integral we have to worry about, or this is the integral we have to worry about, right? So now let's go ahead and set this up and as integration by parts. We'll do u equals 16, 16t dv equals e to the negative t squared. Oh, whoops. Sorry. I deleted it in my mind, but not on the board. So, like I said, the e to the negative t squared goes away. Sorry about that. 16t dt, because e to the power of t squared times e to the negative t squared is, when you multiply them together, you get e to the 0, which equals 1. So these just go away. We're left with the integral of 16t dt. So let's keep going. Y equals e to the negative t squared times, well, the integral of 16t is just 8t squared. And then we'll worry about the constant integration plus c. Take the derivative of this, 2 times 8, 16t. So we know we're good. Now, this is going to be close to your answer. Let's go ahead and distribute this e to the negative t squared. So 8t squared e to the negative t squared plus c e to the negative t squared, right? So this is going to be your solution, right? Yeah, okay. So this is going to be your solution to the differential equation. Now, when we want to evaluate as t approaches infinity, what is y going to do, right? So e to the negative t squared is going to grow a lot faster than just a regular t squared. So this part is going to go to 0. And as with this one, e to the negative t squared is going to go to 0. So as t goes to infinity, y goes to 0, which is, okay. So here's your solution, and this is the end behavior as t approaches infinity. So let's do another one. I'm going to do one more of these, and then I think there are initial value problems with these linear equations as well that I will be going over after this. So, one more problem. Okay, so t y prime minus y equals t cubed e to the negative t, and okay, so we have a problem here because you can't have a t in front of this y prime. You have to divide everything across, right? So we have dividing t across, we have y prime minus 1 over t times y equals t squared, because we're dividing by t, so taking 3 minus 1 is 2, t squared e to the negative t, right? So now this is a form we can work with. Now we can define mu, and we can define g of t. Be careful, because of the negative, those things will mess you up so bad. So e to the integral of negative 1 over t dt is what mu is equal to. G of t equals t squared e to the negative t. Let's simplify mu of t real quick. So the integral of negative 1 over t is going to be negative e to the negative e to the negative natural log of t. And this can be the absolute value of t. I don't believe it specifies in the problem that t is greater than 0. So e to the negative natural log of t. So what this becomes is mu of t is going to be equal to e, and remember from earlier in the video, the negative can just go, that's a -1, it can just go up front. So e to the power of t to the negative first power, so e to the 1 over, e to the 1 over t. E to the natural log of 1 over t. So mu of t is going to be equal to 1 over t. So now that we have mu of t and g of t defined, let's go ahead and plug everything in. 1 over mu of t, well that's 1 over t. 1 over 1 over t is just going to equal t, right? So we're going to use t instead for that first term. So y equals t times the integral of mu of t, which is 1 over t, times g of t, which is t squared e to the negative t dt. These simplify. Y equals t times the integral of t e to the negative t dt. So we're going to have to use integration by parts here. So we're going to have to use integration by parts here. So u equals t. We want that power to descend so we can get it to 0. dv is going to equal e to the negative t. du equals dt, the derivative of u. Du is equal to the derivative of t, which is just dt. And then v equals negative e to the negative t. The integral of e to the negative t is negative e to the negative t. So now let's use parts, and then we have uv, so negative t e to the negative t, minus the integral of v du, so negative e to the negative t dt, v du. So not worried about the constant of integration yet. I always try and worry about the constant of integration when we're integrating the last integral. So let's copy this, or let's go a little bit further up here. Whoops. Yeah. Okay. So y equals t times negative t e to the negative t. I'm pulling this minus out and making this a plus. The integral of e to the negative t, well, that's going to make it a little bit confusing. Let's go ahead and we'll do minus, and then we're going to do the integral of negative e to the negative t, which is just e to the negative t, and then plus c. So, yeah, I think that's the best way to explain it. These get a little confusing because negative, positive, is just stacking on top of each other. Sometimes it just happens. What I did, instead of pulling this out, I just kept the negative sign there, and then I integrated this as normal. The integral of negative e to the negative t is just e to the negative t. So that's what I did. So now we have t times all of this. So we have okay. So y equals negative t squared e to the negative t minus t e to the negative t, and then plus ct. I think that's right. Yeah. Okay. This is going to be your answer. So now what we're going to do is evaluate what happens when t approaches infinity, right? This is the lowest power of t. So this, the value of c here isn't going to really matter whether it's positive or negative. Here we have a negative infinity, but it's approaching 0 faster, so I believe. Yeah, because e to the negative t. So as this grows faster, this is going to shrink to 0. Same here. So as t approaches infinity, y is going to approach 0 for this solution right here. So that's all for this part of integrating factor. I think that there's going to be some with some initial values where we'll be solving for c. So I'll be back with some of those in a different video. Thanks for watching.